Chapter 6.1 talks about the probability model, and it's a description of how statisticians think data are produced. Uniform, linear, normal, and other are things that they talk about here. When you talk about the probability distribution, they abbreviate it as the PDF. What it is a table, graph, or formulas that give all outcomes of an experiment and their probabilities. A random variable is discrete, and they are variables that can be listed or counted. Number of classes taken, number of children in your family, the roll of a die, which means like what you're going to get on it, a 1, a 2, a 3, a 4. Random variables can be continuous if they're not countable, such as time that it takes to finish an exam, how long it takes you to run a race. In your lab work, you don't get an exact value because it can vary and you can't get right down to the 100,000th, something like that. And so that is something else that they say is continuous because it keeps going and going. The length of your thumb, the exact weight, how much you weigh, how much your food weighs, things like that. When you go to classify them as continuous and discrete, again, discrete are countable, things that you can count. Continuous is something that's going to be very difficult to count because, like with time, you can go hours, minutes, seconds, milliseconds, etc. Your discrete probability distribution, it's the most common way to display it is in a table. Usually there's 2 columns. The first one tells you what your possible outcomes are. The second one tells you the probability of that one happening. If you look at this, you're going to see that when you look at the dice, your numbers that you can get on a 6-sided number cube are 1, 2, 3, 4, 5, 6. If your number cube is fair, your probability of getting each of those is 1 out of 6. So they say 1/6. And again, that's if your number cube is fair and if it's a 6-sided number cube. With your raffle, if you have a raffle and they tell you that the cost for your ticket is $5, the chance of winning $95 because you take and you subtract the $5 that you spent on it will be 1%. The chance of winning your $995, which means it's the $1,000 prize, but again, you take away your $5, so that's where they get the $995, is 0.5%. The chance of losing, which means you don't win, so you're negative $5, is 98.5%. When you have a probability distribution table, they have to add up to 1, which means that 100% of your outcomes are accounted for. Examples of graphs with your probability distribution. If you look at this one, they say that the gender distribution of the stats class, they use 0 for female, 1 for male. And so by looking at this, we see that 40% in this class are female. We see here that 60% in this class are male. So again, the 0.4 and the 0.6 have to add up to the 1 to give us 100%. With the Amazon.com ratings, here the number of stars are across the bottom. The probability will always be on the y-axis, the one going up and down. There should be a title on these as well, which they didn't put on there. But on here, what you're going to find is the probability of getting a 1 star is about 0.3 or 30%, etc. across there. If you add up these percents, these decimals, they should add up to 1, which is 100%. continuous data and probability distribution functions, it's often represented with the curve. The area underneath the curve is going to end up adding up to 1, which again represents 100%. And then the curve cannot lie below the x-axis, so it always has to be above the x-axis. Again, the x-axis goes across. Your y-axis goes up and down.